Hi dears, in this video we are going to discuss about the important previous year question from the chapter Equilibrium. As we know, equilibrium is an important topic for JEE exam point of view. A wide variety of questions they can ask from here including numerical. So let's look which all are the questions they asked in the previous year examination. Are you ready? So let's look one by one guys. Come on. So here, this is the first question dears. This is the first question they asked in 2024. So the equilibrium constant for the reaction. One reaction they given. What was the equation they given? What's the equation they given? SO3. SO3 reversibly gives SO2 plus half O2. Okay, half O2. SO3 is a gas. This is a gas. This also a gas. Its equilibrium constant they given. Its equilibrium constant they given what? Kc equal to 4.9 into 10 raised to minus 2. 4.9 into 10 raised to minus 2. Now they are asking the value of Kc for the reaction given below is 2SO2 plus O2 reversibly gives 2SO3. What is actually happening here? That reaction, first of all, we have to reverse. We have to reverse it. So SO2 plus half O2 reversibly gives to SO3. SO3. Okay, gas. So whenever you are having an equilibrium reaction, if you are reversing it, what will happen to equilibrium constant? It will become reciprocal. So 1 by 4.9 into 10 raised to minus 2. That will be the equilibrium constant now. Not over. What's the question? 2SO2 plus O2 gives 2SO3. You have to multiply. After this one, after taking reversal, you have to multiply the entire equation with the 2. Then only you will get what? This given equation 2SO2 plus 2 into 1 by 2 O2, O2 reversibly gives 2SO3. This is gas. Whenever you are multiplying an equation with whenever you are multiplying an equilibrium reaction, reversible reaction with any number, then how it will affect the equilibrium constant? You have to take that number as the powers of equilibrium constant. So that is 1 by 4.9 into 10 raised to minus 2 all square. That's our answer. So once we are solving this one, this 10 raised to minus 2 will go to top. So that will be 10 raised to 4 divided by 4.9 into 4.9. 4.9 into 4.9. Once you are solving, you will get 416 point something you will get. So our answer is what? Option A. Option A is our clear answer. Got it guys? Simple question only they asked in 2020-24. Okay, ready? 2024, ready. We can move to the next question. This is the next question dears. This is the next question. Is a simple, humble question that also asked in 2024. See, here what's the question? The following reaction occurs in blast furnace where iron is reduced to iron metal. Iron extraction method, okay, from hematite. So Fe2O3, that is treating with the carbon monoxide. That oxygen from iron is taken by the carbon monoxide and that will become carbon dioxide. Iron become iron. Iron oxide become iron. Okay, this reaction using Chatelier principle, predict which one of the following will not disturb. Equilibrium will not disturb. So see, here first question, first option, removal of CO2. Whenever you are removing CO2, according to Chatelier principle, they will try to increase the concentration of CO2 by making the reaction, by favoring the reaction towards forward towards product side. So that will affect. Addition of Fe2O3. Yeah, that is our answer. Why? Fe2O3 is what? It's a solid. For pure solid, pure liquid has no effect in equilibrium. Pure solid, pure liquid has no effect in equilibrium. If it is addition of Fe2O3 or removal of Fe2O3 or if you are adding Fe or if you are removing Fe, no effect. Clear? Yeah, that's the answer. Option B is the correct answer. Next we can look about the question number 3. What about the question number 3? This is a simple one. At 20 degrees Celsius and 1 atm pressure, a cylinder is filled with equal number of H2, HI. Okay, equal number of H2, I2 and HI molecule for the reaction. This is the reaction. H2 plus I2 reversibly gives 2 HI. Okay, dears. This is a gas. This is a gas. This is a gas. Then they are asking what is the Kp for the process is x into 10 raised to minus 1. They are asking what is x. So what is Kp? Before that, What about the delta Ng here? Delta Ng, number of moles of gaseous product minus number of moles of gaseous reactant, 2 minus 2. That's equal to 0. Meaning Kp equal to Kc itself. Kp equal to Kc itself, dears. So how I can find out Kc? Kc equal to concentration of Hi. Concentration of Hi square divided by concentration of H2 into concentration of I2. Here number of moles are equal. Automatically this one I can cancel with this 2. So that will be equal to 1 I will get. Because number of moles by volume. That will be equal. Number of moles by volume. This one equal to I can write. If anyone have doubt, number of moles by volume square divided by number of moles by volume. Number of moles by volume. Like that it will come. So we can cancel all. We will get 1. But our option is in terms of 10 raised to minus 1. How I can write 10 raised to minus 1? 10 into 10 raised to minus 1. So x is how much? X is equal to 10. Option C. Don't be get confused with A. Some people will go and answer A suddenly. No. Before you are answering, before you are marking the option, you have to think and you have to do it. Okay, dears? Yeah. Next question number 3. It's a simple question. Simple question. Last year they asked in 2024. What's the question? The ratio of Kp by Kc for the reaction. They given the reaction. You can see CO gas, carbon monoxide gas plus half O2 gas reversibly gives CO2 gas. Clear, dears? Then what's the formula? Kp equal to Kc into RT raised to delta Ng. What is delta Ng here? You can see what is delta Ng here, dear. Delta Ng. In final product, how many gases are there? 1. So 1 minus reactant side, how many gases are there? 1 here, 1 by 2 here. So total 3 by 2. 1 minus 3 by 2. That's equal to minus 1 by 2. So that's equal to, I can take Kc to left hand side. So Kp by Kc. Okay, that's equal to RT raised to minus 1 by 2. That's equal to 1 by root of RT. So which option will come? Option B will come. Clear, dears? That's it. Simple, silly. Okay, we can move to the next question. Question number 5. This is actually, I don't know what to tell. Okay, very simple and humble question they asked me in 2024 again. See, what about the question here? For the given hypothetical reaction, the equilibrium constants are as follows. X reversibly gives Y, equilibrium constant is 1. Y reversibly gives Z, equilibrium constant is 2. Z reversibly gives W, equilibrium constant is 4. Then they are asking the equilibrium constant for the reaction, X reversibly gives W. How I can get this reaction, X reversibly gives W? I have to add this one, this one, this one. 3 equations if I am adding, this YY will get cancelled, ZZ will get cancelled, I will get X reversibly gives W. So whenever I am adding equation, that time equilibrium constant, K equilibrium constant, that final equilibrium constant will be always the product of single each steps. So K1 into K2 into K3. I have to multiply the equilibrium constant. So 1 into 2 into 4, that's equal to how much? 8. So what's the answer? Option C is the correct answer. Simple, right? Yeah, that's why only I told. Okay, yeah, we can move to the next question. Question number 6. I don't know what to tell. This is easier than anyone. Okay, direct question. That's also 2024 question. 2024 question. I'm also feeling like that. Is it a JEE main question? Okay, yeah. So yeah, of course, they asked this question in last year. Okay, see, for the given reaction, choose the correct expression of Kc from the following. Kc, how we can write? Concentration of product divided by concentration of reactants, and their respective stoichiometric coefficients are raised to be their respective powers. So here Fe, SCN 2 plus, okay, divided by concentration of Fe3 plus into SCN minus, option C. I'm not explaining, okay? Yeah, fine. We can go to the next question, question number 7. It's some kind of lengthy question, but idea is simple, okay? Let's look about the question. A reversibly gives B plus C by 2. One gaseous reaction they given. Then they are asking the correct relationship between Kp, alpha and equilibrium pressure P is. Now let's start this. See here A gas, okay, that reversibly gives B gas, okay, B gas plus 1 by 2 into C, that is C by 2. Ready? Let initial moles, okay, listen to me very carefully. Initial moles, I am taking this one, I am taking initially 1. That time this is 0, this is 0. Let alpha be the degree of dissociation, okay? Alpha be the degree of dissociation. Degree of dissociation. Degree of dissociation. Now, at equilibrium, At equilibrium. At equilibrium, how many moles of A are there? 1 minus alpha. 1 minus alpha. How many moles of B are there? Alpha. If one is reacting, one B will forming. How many moles of C are there? Alpha by 2. Alpha by 2. Why I am doing like that? I want to find out the Kp. If I want to find out the Kp, what's the formula here? See, so to find out Kp, I need partial pressure of B, partial pressure of C, partial pressure of A. How I can find out partial pressure of B? Partial pressure of B equal to mole fraction of B into P total. P total value they given. Total pressure is equilibrium pressure is P. How I can find out the mole fraction of B? Mole fraction of B is equal to, you can see mole fraction of B is equal to its number of moles at equilibrium. At equilibrium number of moles is alpha divided by total number of moles. What's the total number of moles here? Total number of moles in equilibrium 1 minus alpha plus alpha by 2. So alpha will get cancelled. So total number of moles is 1 plus alpha by 2. That means that's equal to 2 plus alpha by 2 will come. 2 plus alpha by 2. That I can substitute here. 2 plus alpha by 2. Okay, so number of moles of B divided by total number of moles into P will come. So that is, the 2 will go to top. 2 alpha divided by 2 plus alpha into P. This is the equilibrium, partial pressure of B. And what about partial pressure of C? How I can find out partial pressure of C? See, partial pressure of C equal to mole fraction of B, mole fraction of C into total pressure. What's the mole fraction of C? Mole fraction of C's number of moles is alpha by 2. Alpha by 2 divided by total number of moles that we already find out 2 alpha, 2 plus alpha by 2. That 2 will get cancelled into P. So that means alpha by 2 plus alpha divided by P. Clear? Then how I can find out the partial pressure of A? Partial pressure of A, I can find out like this. See, partial pressure of A equal to, what's the number of moles of A here? What's the number of moles of A at equilibrium? 1 minus alpha. So 1 minus alpha divided by, what's the total number of moles? 2 plus alpha by 2. 2 plus alpha by 2. 2 plus alpha by 2. That is 2 into 1 minus alpha by 2 plus alpha. This is the partial pressure of A. Now how I can write the Kp equilibrium constant in terms of pressure? Partial pressure of C, partial pressure of B into partial pressure of C raised to 1 by 2 divided by partial pressure of A. So I can write like that, partial pressure of B into partial pressure of C raised to 1 by 2 divided by partial pressure of A. What about partial pressure of B? That we already find out as 2 alpha divided by 2 plus alpha into P. Okay, 2 alpha divided by 2 plus alpha into P. Okay, into P. Okay, into, what is partial pressure of C? That also we find out dears. That also we find out. Here already we are having the value alpha divided by 2 plus alpha into P. Alpha divided by 2 plus alpha into P all raised to 1 by 2 all divided by partial pressure of A we already find out here. 2 into 1 minus alpha divided by 2 plus alpha. I can cancel the values like 2 plus alpha I can cancel. Okay, here one P is there. Okay, I'm sorry. That P I can cancel. And 2 I can cancel. 2 I can cancel. What is remaining there? You can see here on the top alpha is there. Alpha into here alpha raised to 1 by 2. Okay, alpha raised to 1 by 2. P raised to 1 by 2. Divided by you can see 1 minus alpha into 2 plus alpha raised to 1 by 2 is there. That means alpha into alpha raised to 1 by 2, alpha raised to 3 by 2 into 3 by 2 into P raised to 1 by 2 into 2 plus alpha raised to 1 by 2 into 1 minus alpha. That is Kp. So let's look about the option. What about the option here? Alpha raised to 3 by 2, P raised to 1 by 2, 2 plus alpha raised to 1 by 2, 1 minus alpha. Option D is the correct answer. Clear dears? Yeah. If it is concentration related means you have to divide that number of moles divided by volume. Then you can find out in terms of concentration you can write. If it is pressure related means we have to find out the total number of moles and we have to go like this. Clear? We can move to the next question dears. Question number 8. Question number 8. This also they asked in 2023. The same way they asked in 2023. Let's look about the question. For a concentrated solution of a weak electrolyte, okay, weak electrolyte, equilibrium constant KEQ, A2B3. That's a weak electrolyte, A2B3. A2B3. How it is dissociating dears? How it will dissociate dears? You know the dissociation? That will be A2B3, right? Yeah, A2B3. Yes, fine. A2B3. It will dissociate like 2 A3 plus 2A3 plus 3B2 minus. Like that they will dissociate. Now they given initial concentration they given dears. In terms of concentration they are asking. Initial concentration is C. That time its concentration is 0, its concentration is 0. Starting. Let alpha be the degree of dissociation. Alpha be the degree of dissociation. Okay, degree of dissociation. Then they already given degree of dissociation alpha. Then at equilibrium, dears, at equilibrium, how much amount of A2B3 is there? C minus C alpha. Alpha portion of C is reacted. So remaining is C minus C alpha. How much amount of A is produced? If 1 is reacted, 2 will be produced. So C alpha reacted, 2 C alpha will be produced. If 1 is reacted, 3 B2 minus will be produced. So how many B2 minus will be produced when C alpha reacted? 3 C alpha will be produced. Clear? Now what we want to do? They are asking to find out that relation, K equilibrium, that relation we have to find out. So K equilibrium equal to, you can see dears, K equilibrium equal to, how I can write the K equilibrium? Concentration of A3 plus all raised to 2, okay, all raised to 2 into concentration of B2 minus all raised to 3 divided by B2 minus all raised to 3 divided by concentration of A2B3, okay, concentration of A2B3. What's the concentration of A3 plus all square? A3 plus all square is how much? 2C alpha. So 2C alpha all square, okay, into B2 minus how much? 3C alpha all raised to 3 divided by concentration of A2B3 how much? C minus C alpha, that is C into 1 minus alpha. Clear? That's equal to K equilibrium. Now I can cancel the things. 2 raised to 2 means 4. 4 C square alpha square. 3 cube means 27. 27 C cube alpha cube divided by C. Why I am not writing 1 minus alpha? Because I know that it's a weak electrolyte. Alpha is very much less than 1. So 1 minus alpha approximately equal to 1. That's why I am not writing. I am writing only C. Correct? I can cancel C, I can cancel. Then now C into C cube. That is C raised to 4. Okay? C raised to 4 will be there. 4 into 27. 108 will come. 108 C raised to 4. Alpha raised to 5 will come. Alpha raised to 5. From that I can find out K equilibrium. K equilibrium is equal to, I will write here. You can see alpha raised to 5 equal to, what is coming? K equilibrium divided by 108 C raised to 4. So alpha equal to what? Fifth root. So that means K equilibrium by 108 C raised to 4 raised to 1 by 5. Option B is the clear answer. Ready? Yeah. We can move to the next question, dears. Question number 9. It's a simple, humble question. Consider the following reaction. They given one reaction. This is in 2020 they asked, okay, related to Chatelier principle. N2O4 reversibly gives 2NO2 delta H0 plus 58 kilojoule. What's the meaning? Forward reaction is endothermic and backward reaction is exothermic. That we can mark. Ready? Now for each of the following cases 1 and 2, direction in which the equilibrium shift is. First case, temperature is decreased. Whenever temperature is decreasing, exothermic reaction will take place. Which is exothermic here? Backward reaction is exothermic. Temperature decreases, exothermic. Temperature increases, endothermic. That we know. We don't know whether it is forward or backward. But in this case, exothermic is backward. So exothermic will take place. Whenever temperature decrease, exothermic will take place. Exothermic is backward. So reactant side reaction will take place. So in first case, towards reactant. Okay, towards reactant reaction will take place. That's okay. Next one, pressure is increased by adding N2 at constant temperature. N2, in this case, N2 have no effect. N2 is just like treated like what? A noble gas. No effect on that one. So that means no change. 2 is no change. So option C is the correct answer. Clear, dears? Okay, perfect. Okay. Next question, question number 10. They asked in 2020 again. See, you can see in the figure shown below, reactant A. So reactant A, okay, that reversibly gives what? Is in equilibrium with the product B. And A is represented by square. How many squares are here? 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. 6 squares are there. So its concentration is 6. Okay. What about the equilibrium with the product B? Represented by circle. How many circles are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 circles are there. Now they are asking equilibrium constant. Directly you can write equilibrium constant is equal to concentration of B divided by concentration of A. So 11 by 6 will come. 11 by 6 means how much it will come? You can see 11 divided by 6, 1, 6, 6. Then remainder is 5. I can take 50. So 8, 6 are 48. 1.8. 1.8 is the answer. Here there is no 1.8. So nearer to 1.8, the integer is 2. 2 is the correct answer. Clear, dears? So dears, this is the next question. Consider the following reversible chemical reaction. They are given a chemical reaction A2 plus B2 reversibly gives 2AB. Okay, 2AB. This is first reaction. Its equilibrium constant they are given K1. And second reaction 6AB reversibly gives 3A2 plus 3B2. Its equilibrium constant is K2. Now they are asking the relationship between K1 and K2. So what's the idea? So you see, this is K1. Okay. So how we are getting this one? First of all, I want to reverse this one. If I am reversing that one, see 2AB, okay, reversibly gives, okay, you can see A2 plus B2. Whenever I am reversing this one, its equilibrium constant become reciprocal. So 1 by K1, okay, it will be become 1 by K1. Not over. To get this equation, I have to multiply that entire thing with 3. So if I am multiplying entire thing with 3, it will be become 6AB, reversibly gives 3A2 plus 3B2. That time, this will be become, whenever you are multiplying with a number, that will be become power of the equilibrium constant. So 1 by K1 all cube. That is equal to K2. So K2 equal to 1 by K1 all cube. Meaning K2 equal to what? K1 raised to minus 3. K1 raised to minus 3. Is there any option like that? Yes. See, K2 equal to K1 raised to minus 3. That relation. But whenever we are changing the equilibrium reaction, mode of equilibrium reaction, how it will affect the equilibrium constant. That idea, if you know, means you can answer one question from here. Clear, dears? Yes. We can move to the next question. See, next question, once we are looking at the 12th question, what about the question here? So here the question is 5.1 gram NH4HS. Okay. That is introduced in 3 liter evacuated flask at 327 degrees Celsius. Okay. 30% of the solid NH4SH decomposed to NH3 and H2S gases as gases. The Kp of the reaction. So first of all, we have to write the reaction. What about NH4HS? See, this is I will write here. We can use the new slide. Okay, so NH4SH. Okay, new page. NH4SH. It's a solid. Okay, this one once it is dissociating. How it is dissociating, dears? It will dissociate as NH3 gas, ammonia gas, and H2S gas. Okay, so it is a solid. But instead of giving the number of moles, they given what? They given 5.1 gram. Okay, 5.1 gram NH4SH. But we need the number of moles. Then only we can find out the Kp, because we have to find out the mole fraction. So automatically we need number of moles. That we know how to go to find out what? Kp. We know the steps, procedures. So what I will do? I will convert this one into number of moles. Number of moles equal to given mass by molar mass. So I need the molar mass of NH4HS. What's the molar mass? NH3 is 17, NH4 is 18. Then sulfur is how much? 32. 32 plus 1, 33. While you are adding 1, 51 we will get. So 5.1 gram means number of moles equal to 5.1 divided by 51. That's equal to 0.1 I will get. 0.1 moles. So idea is you are initially taking initial moles of, listen to me very carefully, initial moles is equal to, initial moles of NH4SH equal to 0.1 mole. That time NH3 is 0, H2S is 0. Now they are telling, what they are telling, dears? What they are telling? You can see 30% of the solid NH4SH decomposed to NH3 and H2S. Okay, so 30% dissociated. 30% meaning what? Alpha equal to 30%. 30% is equal to 30 divided by what? 30 divided by 100. 30 divided by 100 dissociated. Okay, 30 by 100 dissociated. That means that's equal to 0, 0 will get cancelled. 0.3 dissociated. Okay, 0.3 dissociated. 0.3 of, this is actually alpha. That means 30% means 0.3 dissociated. From where? That 0.1, its 0.3 is dissociated. 0.1, its 0.3 is dissociated. So, at equilibrium, once you are solving at equilibrium, how much is remaining here? 0.1 minus 0.1's 0.3 remaining. 0.1's 0.3 reacted. Okay, because if you are taking 1, its 0.3 is reacted. You are taking 0.1, its 30% reacted. Understood? 0.1 30% reacted. That means 0.1 30% means 0.1 into 0.3. That means if 1 is reacted means here 1 will form. Clear? So 0.1 into 0.3 reacted means here 0.1 into 0.3 formed. And here also how much formed? 0.1 into 0.3. That means that's equal to 0.03. Here also 0.03. That idea you know. Now what we can do? We can find out Kp. Kp equal to what? Kp equal to partial pressure of NH3. Okay, partial pressure of NH3 into partial pressure of H2S. Partial pressure of H2S. They are asking us to find out the Kp. Clear? So partial pressure of NH3 into partial pressure of H2S. How I can find out the partial pressure of NH3? Mole fraction of NH3, okay, into P total into mole fraction of H2S into P total. So we need P total. How we can find out P total? To find out P total, they given, we are having the equation PV equal to nRT. PV equal to nRT. So P equal to nRT by V. nRT by V. We can substitute the values. See dears, we can substitute the values. How we can substitute the values? We are having PV equal to nRT. So P equal to nRT by V. So what's the total number of moles? At equilibrium, what's the total number of moles? We don't want to consider NH4SH. Why? Because it is a solid. No need to consider that one. We have to consider only ammonia. Ammonia is 0.03. H2S is 0.03. So 0.03 plus 0.03. That's the total number of moles. 0.03 plus 0.03. Okay, 0.03 into R value. R value they given in terms of what? R value 0.082. That we can substitute there. 0.082. What about temperature, DS? In the question, they given temperature is 327 degrees Celsius, meaning 600 Kelvin. Okay, 600 Kelvin divided by volume. Volume is equal to how much they given? 3 liter they given. 3 liter. That also we can give the value here. 3 liter. So once we are solving this one, we will get how much? 0.984 we will get. 0.984. 0.984 ATM we will get. Clear? So the mole fraction of NH3, you see at equilibrium, its number of moles as well as its number of moles is equal. Then how we can find out the number of mole fraction of NH3? So 0.03 divided by total 0.06. That means 1 by 2. 1 by 2 into P. P is 0.984 into 1 by 2 into 0.984. So once you are solving, you will get the answer. First answer you will get 0.242. That's equal to 0.242 you will get 0.242. 1 by 2 into 0.984 into 1 by 2 into 0.984. So your answer will be what? 0.242 ATM squares. Option B is the correct answer. Guys, you got it? Yeah, that's it guys. So we can move to the next question. Question number 13. Question number 13. Here you can see they given, consider the reaction. They given one reaction N2 plus 3H2 reversibly gives 23 gas. It's a 2019 question. Okay, it's a very important question. Listen very carefully. So the equilibrium constant of the above reaction is Kp. This reaction is Kp. Now they are asking if the pure ammonia is left to dissociate. Some ammonia, pure ammonia is there that is dissociating. Okay. Partial pressure of ammonia at equilibrium is given by. At equilibrium, what is the partial pressure of ammonia? So we have to take the dissociation of ammonia. So just a reverse we have to take. Just a reverse means how I can take, dears. How I can take. See how I can take. You can see here. I will take it is this one. You can see N2 plus 3H2 that reversibly gives 2NH3. Okay, 2NH3. Its equilibrium constant they given it is Kp. Am I correct? That is given Kp. For this one Kp. So now we have to take the reverse. Reverse means 2 ammonia that is dissociating it into N2 plus 3H2. This time equilibrium constant is 1 by Kp. 1 by Kp. Clear? Yes. Now listen to me. What's the total pressure of the system? What's the total pressure of the system? Total pressure P total. Okay. That's equal to P. Equal to at equilibrium P total equal to how I can calculate partial pressure of N2 plus partial pressure of H2 plus partial pressure of ammonia. But in the question they given partial pressure of ammonia is very much less than P total at equilibrium. So what we can eliminate here? This ammonia we can eliminate. So only P total equal to what? Partial pressure of N2 plus partial pressure of H2 alone. Partial pressure of N2 plus partial pressure of H2 alone. Okay. Then how I can find out the partial pressure of N2? Partial pressure of N2 at equilibrium, total number of moles, this one is 1, this will be 3. This one will be 1, this will be 3. So total number of moles 1 plus 3. We don't want to consider this one. This is negligible. So 1 plus 3 means total 4 moles are there. Out of that 1 mole is nitrogen. So 1 by 4 into P total. That will be the partial pressure of nitrogen. What about the partial pressure of hydrogen? Partial pressure of hydrogen is equal to that similarly 3 by 4 into P total. 3 by 4 into P total. Okay. 1 by 4 into P total, 3 by 4 into P total. That also we got. Now, what they are asking us to find out? What they are asking us to find out? They are asking us to find out the partial pressure of ammonia at equilibrium is given by. At equilibrium, what's the partial pressure of ammonia? What's the partial pressure of ammonia? So we know the relation Kp equal to, for this reaction, okay, I'm sorry, for this reaction, equilibrium constant. For this reaction, equilibrium constant how much? 1 by Kp. That 1 by Kp equal to how I can write? Partial pressure of N2 into partial pressure of H2 all raised to 3 divided by partial pressure of ammonia all square, dears. Ammonia all square. I can take that partial pressure of ammonia all square into left. Partial pressure of ammonia all square equal to this Kp will go to top. Kp into partial pressure of N2 into partial pressure of H2 all cube. So we can substitute the values. What's the values? I will substitute the value, dears. Partial pressure of NH3 square, okay. Partial pressure of NH3 square equal to, what about the values, dears? For Kp, Kp itself, okay. For Kp, I can write Kp itself in terms of Kp only in the options. You can see. Then partial pressure of N2, how much? Partial pressure of N2 is equal to 1 by 4 into P. So 1 by 4 into P, okay. 1 by 4 into P. Then what is remaining? Partial pressure of H2 all cube. Partial pressure of H2 all cube is equal to H2 how much? 3 by 4 into P. So 3 by 4 into P, okay, all cube. All cube. Am I correct? Partial pressure of H2 all cube, okay. Yes. So now that is equal to Kp into P divided by 4, okay, this 4 into 3 cube means 27. 27 P cube divided by 4 cube means 64. Am I correct? This is equal to partial pressure of NH3 all square. All square. So that is equal to, I can write it is, you can see, dears, you can see this P into P cube, P raised to 4 into Kp into 27 divided by 4 into 64. Then what is partial pressure of NH3? Partial pressure of NH3 means I have to take the square root. I have to take its square root. That means P raised to 4 into Kp into 27 divided by 4 into 64 all raised to 1 by 2. That's equal to P raised to 4 raised to 1 by 2 means P square. Okay. Kp raised to 1 by 2 means root Kp. Root Kp into 27 raised to 1 by 2 means 27 means I can write it is 3 cube. So 3 cube raised to 1 by 2, 3 raised to 3 by 2. Okay. Divided by 3 raised to 3 by 2. Divided by root of 4, 2. Root of 64, 8. So 2 into 6, 16. So that will be the answer. P square into root Kp into 3 raised to 3 by 2 divided by 16. Is there any option like that? Yes. 3 raised to 3 by 2. Kp raised to 1 by 2. That is root Kp into P square divided by 16. Option C is the correct answer. Clear, dears? Yeah. That's it. So whenever you are patiently solving, you will get the answer. That's it. So up to this much, I mean, we did 13 questions. You may see like that previous year, they are asking that Kp related question, Kp alpha relation. That you must have to focus. You must have to do a lot of questions from there. Ready? Yeah. We can move to the next question. Question number 14. Question number 14. What about the question here? Two solids, okay? Two solids dissociate as follows, okay? Two solids are there. A solid is there. That is dissociating like what? B gas plus C gas, okay? B gas plus C gas. Its equilibrium constant Kp1 equal to how much? X ATM square they given, okay? Suppose if it is dissociating, I am taking B's pressure is P1 and C's pressure also how much? P2. Partial pressure of B is P1 and C also, P1. Both will be same because same number of moles we are getting, so same. Next, at the same time, I am dissociating, okay. I am dissociating D solid also, that is giving C gas as well as E gas. So let's take its pressure is P2 and its pressure also P2. But simultaneously together we are doing this one means, you can see from here also we are getting C, from here also we are getting C. So this C will be P1 plus P2, here also P1 plus P2. That's the difference you have to remember, nothing more. Together we are doing. Its equilibrium constant is X. Its equilibrium constant is Kp2 is Y. Now how I can relate, dears? How I can relate? You can see, if I am adding, how I can write this Kp1 X equal to, how I can write? Partial pressure of B into partial pressure of C. That's equal to how much? Partial pressure of B is how much? P1 into P1 plus P2. Okay, P1 into P1 plus P2. That's equal to P1 square plus P1 P2. Ready? Yeah. Next, Kp2 equal to Y. How I can write? Partial pressure of C into partial pressure of E. Why I am not taking D and A? They are solids, no need. So that's equal to P2 plus P1 into what? Into P2. So that is P2 square plus P1 P2. Ready? Clear? Now if I am adding, see, you can see if I am adding X plus Y equal to, I will get P1 P2 plus P1 square plus again P1 P2 plus P2 square. That's equal to P1 plus P2 whole square equal to X plus Y. Meaning P1 plus P2 equal to what? Root of X plus Y. P1 plus P2 equal to root of X plus Y you will get. But our question is the total pressure when both the solids dissociate simultaneously. What's the total pressure? When both are simultaneously dissociating means in that cylinder B is there, C is there as well as E is there. Then what's the total pressure? Total pressure P total equal to partial pressure of B plus partial pressure of C plus partial pressure of E. Partial pressure of B plus partial pressure of C plus partial pressure of E. What's the partial pressure of B, dears? Partial pressure of B is P1 plus partial pressure of C. Partial pressure of C is P1 plus P2. What's the partial pressure of E? P2. So this is equal to how much? 2 times P1 plus P2. 2 P1 plus 2 P2 means 2 times P1 plus P2. 2 into P1 plus P2 how much? Root of X plus Y. So P total equal to what? 2 into root of X plus Y. Option C. Clear, dears? Yeah, that's all. We can relate them. We can easily relate them. If you know the basic ideas, fundamentals, if you know means we can easily. Here the thing is that only one thing. Here C is getting from the solid A as well as C is getting from the solid D. So automatically both the cases, both the pressure we have to add together, that both pressure will be same. From here also we are getting C, from here also we are getting C. So both gases will make a total pressure. That we have to keep it in mind, then we can solve. This is just like simultaneous solubility also you did. That also we will do one video in next equilibrium 2. We will do that solubility related, simultaneous solubility related questions also we will do it, dears. Okay. Anyhow, we can go to the next question. Question number 15. See, what's the question here? A solid XY, okay. A solid XY, you are kept in an evacuated sealed container, okay. There is no other gas, okay. Undergoes decomposition to form a mixture of X and Y at a temperature T. The equilibrium pressure is 10 bar, okay. The equilibrium pressure is 10 bar. Then Kp for the reaction is, what's the Kp? Kp equal to partial pressure of X into partial pressure of Y. What is partial pressure of X? Mole fraction of X into P total into mole fraction of Y into P total. At equilibrium, what's the mole fraction? Here both are same, this one only we have to consider, both are gases. Here it is solid, no need to bother about this one. Its number of moles will be equal to its number of moles. So it will be total mole fraction is 1. So this will be 1 by 2, this will be 1 by 2. So 1 by 2 into P total how much? They given, it is 25, it is 10 bar, okay. So 10 into, okay, what X to XY how much? Mole fraction of Y how much? That also 1 by 2 into 10. So that means 10 by 2 means 5. 10 by 2 means 5. 5 into 5, that's equal to how much our answer? 25 is our answer. Easily you can solve option A. Clear? Yes. We can move to the next question. Question number 16, dears. Question number 16. Gases N2O4 dissociate into gases NO2 according to the reaction. They given one reaction. N2O4 is dissociating like 2NO2. Okay, 2NO2. Ready? And at 300 Kelvin and 1 atm pressure, the degree of dissociation of N2O4 is 0.2. Okay. If 1 mole of N2O4 gas contained in a vessel, then density of equilibrium mixture is, you are taking initial number of moles. Okay, initial number of moles of N2O4 1. That time this is 0. Then you are telling 0.2 is the, in the question they are telling degree of dissociation is 0.2. Then at equilibrium 1 minus 0.2, from that 0.2 reacted, 1 minus 0.2, that means 0.8 will be remaining there. If 0.2 is reacted, if 1 is reacted, 2 will be forming. So 0.2 reacted means 2 into 0.2, that's equal to 0.4 will form here. 0.4 molecules of 0.4 moles of NO2 will form there. Now what we have to find out? The density we have to find out. So first of all we have to find out what? Their Kp value we have to find out. Okay, sorry, we must have to find out. Whenever we are having to find out the density means we need the total mass of the mixture. So the molar mass of mixture, okay, molar mass of mixture is equal to its mole fraction how much? 0.8. So 0.8 into its molar mass of N2O4, okay, plus its mole fraction, that is 0.4, into its molar mass of NO2 divided by total mole fraction how much? 0.8 plus 0.4, that is 1.2. You have to multiply 0.8 into molar mass of N2O4. You can calculate the molar mass of N2O4. Molar mass of N2O4 is how much? This is 28, dears. This is 28. And O4 means 4 into 16. 64 it will come. Correct? 64 it will come. Am I correct? Ready? Yeah. So 8 plus 4, this will be 2. This will be 9. 92 will come here. 92. So 92 plus 0.4 into NO2. If it is 92 means this will be 46. This will be 46. Just half only that one. Divided by 1.2. Once you are solving this molar mass of mixture, you will get the answer 76.66. That's the molar mass of mixture. Then how you will find out the density? You are having the formula. Density is equal to Pm by RT. Okay, from ideal gas equation only we are deriving Pm by RT. So what's the pressure here? Pressure they given in the question 1 atm. 1 atm. That 1 we can give. Okay, 1 we can give. Molar mass how much we find out? 76.66. What's the R value? R value is 0.0821 because in atm we are doing 0.0821. What's the temperature value, dears? Temperature value they given 300. So that's equal to how much? 300. Once you are solving this one, you will get the answer 3.11 you will get. So our answer is what? Option B is our answer, 3.11 gram per liter. On simple way we can solve it. Ready? Yes. So question number 16 is over. We can go to question number 17. What about the question? It's an easy question. In case of, okay, the increase of pressure on ice water system. So ice is there at 0 degrees Celsius, it is possible, correct? Ice water equilibrium. Okay, ice water equilibrium. You know that here the volume of ice is more. Volume of ice is more, okay, and volume of water is less. At 0 degrees Celsius, okay, volume of water is less. At 0 degrees Celsius we are discussing, okay, at 0 degrees Celsius this one is happening, okay, because up to 4 degrees Celsius whenever you are heating, this water will what will happen to them? They will come closer, then after that only they will expand. That idea you learned, okay, yeah. So here in between ice a lot of cages will be there, whole space will be there because of what? That intermolecular hydrogen bonding. That is the basic idea you know. Now what they are telling? Increase of pressure. Whenever you are increasing pressure according to Le Chatelier principle, they will try to decrease it. So which direction the reaction will take place? Volume is lesser, that direction reaction will take place. So forward direction reaction will take place. So what's the answer? A shift to the equilibrium in the forward direction C. So whenever you are applying pressure, that will become melt. That will melt. That's it. Clear? So that will melt to form what? A lot of water molecule. That's it. So our answer is what? Option C. Clear, dears? Yes. We can move to the next question, question number 18. This one we already did. Answer is A. So that SO2, SO3 question we did already. So we have to reverse it. Okay. We have to reverse it and we have to square it. So that will be 416. Okay. Next one, question number 19. What about the question here? Phosphorus pentachloride. Okay. PCl5. It's an easy question. Again, they asked this one in 2006. Okay. That time also they are asking the same question. Okay. PCl3 plus what? Cl2 gas. This is gas. This is gas. This is gas. Now, they are asking the total pressure of equilibrium mixture is P and the degree of dissociation of PCl5 is X. Then partial pressure of PCl3 will be. So, what's the initial moles? Initial moles I can take it is how much? Initial moles is equal to 1. That time this is 0, this is 0. X is the degree of dissociation. Then at equilibrium this will be 1 minus X, this will be X, this will be X. Fine, finish. Then they are asking the partial pressure of PCl3. Partial pressure of PCl3 equal to mole fraction of PCl3 into P total. Into P total. Mole fraction of PCl3 means the number of moles of PCl3 at equilibrium X divided by total number of moles of gases at equilibrium 1 minus X plus X plus X. That is 1 plus X into P will come. That's it. X by 1 plus X into P. Option A is the correct answer. Clear? They are directly asking partial pressure of PCl3. That's it, guys. Clear? Okay. We can move to the next question. Question number 20. Question number 20. What about question number 20? They given one reaction. For the reaction 2NO2 reversibly gives 2NO plus O2. Okay, it's Kc value they given. Now they are asking when Kp and Kc are compared at 184 degrees Celsius, found that. What is the relation between Kp and Kc? We know Kp equal to what? Kc into RT raised to delta Ng. What's the delta Ng here? Here in the product side 2 plus 1. Total 3 gaseous molecules are there. Left hand side 2 are there. So delta Ng equal to how much we will get? 3 minus 2 equal to 1. 3 minus 2 equal to 1. Meaning Kc into RT raised to 1 will get. That means whenever you are multiplying Kc with the RT, then only you are getting Kp, means Kp is always greater than Kc. So what's the answer? Kp is greater than Kc. Option A. So we did 20 important questions they asked previously. That also from the chemical equilibrium portion. So that also you understood what? You understood what? They are mainly relating Kp, Kc, then alpha, that relation. That you have to practice maximum question, dears, maximum question. I will come with the next video with ionic equilibrium, that portion. I mean equilibrium 2 we will come with. We will solve a lot of questions PYQ from the ionic equilibrium. We can meet there. Up to that, thank you.